Today I want to talk about prisms and pyramids, and then how to find the surface area and volume of a prism. So let's start talking about prisms. And here I have a box of oatmeal that I took out of the closet, and this is an example of a prism. What makes it a prism is that the top and the bottom are the same shape. In this case, it's a rectangle, and the sides are all rectangles. They don't have to be the same size, but they all have to be rectangles. So that's what makes something a prism. This is a rectangular prism because the top and the bottom are rectangles. Now here is another prism this is a triangular prism. The top is a triangle and the bottom is also a triangle. They are the same size, same shape, they are congruent, and the sides are rectangles. So that means this is a prism. Now prisms can be, the top and the bottom can be any shape you want as long as the sides are rectangles. So this is a triangular prism. But you can have hexagonal prisms, octagonal prisms, dodecagon prisms, any kind, square prisms, any kind where the bottom and the top are the same shape and the sides are rectangles. So that's what makes this a prism. It's got two bases that can be any shape. They have to be congruent. Must be congruent. And sides are always rectangles. And so any shape where the bases are the same and the sides are rectangles would be a prism. Now here's another shape that I found walking around my house. My husband works for PG&E, so he had this on his desk. This is not a prism. This is a pyramid. Now what makes this a pyramid is that the bottom and the top are different. The bottom can be any shape. In this case it looks like a square, and the top is always a point. One point. So that makes the sides, instead of rectangles, the sides are always triangles. And you can have all kinds of pyramids. This one is a square pyramid, but you can have a triangular pyramid or a hexagonal pyramid or an octagonal pyramid. Whatever the bottom is defines it. And the pyramid is because it has the pointy top. So a pyramid only has one base, can be any shape, as long as it has sides, and it has a point on the top, and the sides are always triangles. So that's the difference between a pyramid and a prism. Now today I want to talk about how do you find the surface area of a prism. So we're not going to talk about pyramids today, just prisms. So looking at my cereal box, I see that I have one surface, two surfaces, three surfaces, four surfaces, a top and a bottom. 6 surfaces. And I need to find the area of each one and then add them all together. So I'm going to have to do some measuring. So I'm going to use centimeters. Looking at this, looks like I have 15 centimeters by 18 centimeters. So the front is 15 by 18. Now the back is going to be the exact same as the front in a rectangular prism. So I'm going to have 2 of those. Now I have a top and a bottom. My top, I know this part is 15 because I just measured it on this front. This is 15. But it's 15 by, looks like 4.5. So 15 times 4.5. These are all centimeters. And there'll be 2 of them. There's the top and there's the bottom. Now I still have 2 more surfaces. I have the right and I have the left. And again, they're going to be the same. So I've got 4.5, and this way is 18. So 4.5 times 18. And there's 2 of each of these. So let me grab my phone, my calculator, and let's see. We've got 15 times 18, and that's 270. And like I said, there's 2 of them. So that's 540 centimeters squared, because we're talking about area. This was centimeters times centimeters. That's going to be centimeters to the 2nd power. And then I've got 15 times 4.5. That's 67.5. And there's 2 of them. So that's 135 centimeters squared. And then the third one is 4.5 times 18. That's 81. And again, there's 2 of them. So that's 162. And then you just add them all together. So 162 plus 135 plus 540 is 837 centimeters squared. So that would be the surface area. If I wanted to cover this with paper, that would be how much paper I would need. Now what if I want to open it up and I want to find out how much the stuff, how much oatmeal will fit inside? Well, if we were at school, we would have these little wooden cubes that are 1 centimeter by 1 centimeter, and we would figure out how many cubes fit in this box. I'll put my oatmeal back in. So in order to find volume, I'm going to figure out the area of the base, which I already figured out, and then I'm going to multiply it by the height, and that's going to tell me how many layers were in this box. If this is the bottom layer, we said the bottom was 67.5, and there's another one, and another one, and another one, and another one, and another one, all the way up to 18 inches. There's 18 layers of this bottom. Okay, so we said the base, capital B for base on this one, was 67.5 centimeters squared. That was the area of the bottom. And my height is 18. So I'm going to multiply. So that's 67.5 times 18. That's 1,215. Now I had centimeter squared times another centimeter. Now I have centimeter to the 3rd power, which is the 3rd dimension, and that's called cubed. So 1,215 cubic centimeters. So to find the volume, it's always whatever the shape of the base is, find the area of that and multiply it times the height. In a rectangular prism, to find the area of the base was length times width. So for a rectangular prism, to find the volume, it's length times width times height. But that only works for rectangular prisms. What if you have another prism, like this prism? This formula here will work for any prism. Now, here we have a prism where the base is this triangle. Sometimes you'll see them in problems where they'll turn it on its side, or maybe they'll put the triangles on this side, and they'll have the rectangle on the top, but you have to realize that you can turn it this way. So here we've got a triangular prism. We need to find the area of the base. And the base is a triangle. So to find the area of the triangle, it's base times height divided by 2. So my base looks like it's 8 centimeters. And my height looks like it's 4 centimeters. And I want half of that. So 8 times 4 is 32. Half of 32 is 16 centimeters squared. So that's the area of the bottom. And how high is it? It is, looks like it's about 6 layers, a height of 6. So if the height is 6, it's going to be base times height. So 16 times 6, which is 96 centimeters cubed. So again, it was base times height. The base was the triangular, was 96. The height was 6 centimeters, and I multiplied, or this was 16, sorry, 16, and I multiplied them together and got 96. So again, that's volume. Let's go back and look at one more thing. Let's look at surface area of this prism. So again, the words kind of tell us what we're doing. We're finding the area of every single surface and adding them together. So I already found the area of this triangle when I was working on volume. I found out that it was 16. So that means this side is also 16. So I've got 2 of those. 16 and 16 is 32. So that's for the triangle pieces. Now for the rectangle pieces, they're not always the same. If I look at this triangle, it looks like this is an isosceles triangle. So these 2 rectangles will be the same. Let's see if I'm on the picture. These 2 will be the same. This one's going to be different because this side is different. If you had a scalene triangle, all the rectangles would be different. And if you had an equilateral triangle, all the sides would be the same. So let's figure out what each side is, and then we'll add everything together. So using centimeters, this side looks like it's about 6, and 6 by 6 by 6. So this looks like it's a 36. And this one is also 36, which makes sense. If that was an isosceles triangle, these 2 sides would have to be the same. But this side's going to be different. This is a little bit like maybe 8.5 times, how can that be different than this? This is 6, this should be the same. Okay, so this is 6 by 8.5, 8.5. So 6 times 8.5 is 51. So one side was 51. One side was 36, the other side was 36, and the 2 triangles were 32. And then I'm going to add them all together. 6 plus 6 is 12, plus 1 is 13, plus 2 is 15, carry your 1. 3 plus 3 is 6, 6 and 5 is 11, plus 3 is 14, plus 1 is 15. And so this would be centimeters squared. So the surface area, the outside of this shape, would be 155, and the inside would be 96. In other words, 96 little cubes would fit inside of here. And if I wanted to wrap it in paper, I would need 155 square centimeters of paper. So that's the difference between volume and surface area. Surface area, you just have to find the surface, the area of every surface, and add them all up. Volume is always base times height. And remember the difference between a prism and a pyramid.